Today we are going to see one new topic related to design, that is design of levers. As we have successfully completed the design of mechanical joints including knuckle joint, turnbuckle and quarter joint. So now we are going to start the design of levers. Okay. So let us see what doing by levers is and how it is going to be designed. Please see. See guys, first point what it is mentioned here. A lever is a rigid rod or bar capable of turning about a fixed point called fulcrum. See guys, very easy, very well written. A lever is a rigid rod or bar. Okay, it is a rod or bar capable of turning about a fixed point, which can easily turn about a fixed point, which is called fulcrum. See, the fulcrum is called as fixed point of lever. Okay, if you see any lever which is turning about a fixed point, so that fixed point is called as fulcrum. Okay, then it is used as a machine to lift a load by the application of small effort. See guys, it is used as a machine. Okay, you can term a lever as a machine which is used to lift a load by the application of small effort. Just by applying small effort you can easily lift a heavy load with the help of this lever. Then the ratio of the load lifted, see guys, it is very important. The ratio of the load lifted to the effort applied, see guys, the ratio of the load lifted to the effort applied is called mechanical advantage. Please see what it is. The ratio of the load lifted to the effort applied is called mechanical advantage. What do you mean by mechanical advantage? The ratio of load lifted to the effort applied, okay, is called mechanical advantage. Sometimes a lever is merely used to facilitate the application of force in a desired direction. A lever may be straight or curved. See guys, what it is written over here, a lever may be straight or curved, and the forces applied on the lever or by the lever, see guys, or the forces applied on the lever or by the lever may be parallel or inclined to one another. The principle on which the lever works is same as that of moment. See guys, the principle on which the lever works is same as that of your moments. Okay, we are going to take moments about one fixed point, so same principle we are going to apply in the lever. Okay, this is lever. Lever means what? It is a rigid rod or bar which is capable of turning about a fixed point, which is called as fulcrum. So fulcrum is called as a fixed point about which your lever or rod is going to be turned. Then why it is used? Lever is used as a machine. Okay, why? It is used as a machine to lift a load by the application of small effort. Okay, the ratio of the load lifted to the effort applied is called mechanical advantage. Okay, so lever may be straight or curved, and the principle on which the lever works is same as that of your moments. Okay, so let us see what next. So you can see what heading I have given here, common examples of levers. Please guys, common examples of levers. So first of all, let us take this example that you are going to see one arm. Okay, human arm. So you can see what we said, a lever is a rigid rod or bar which is capable of turning along a fixed point which is called as fulcrum. So let us take the example of an elbow of human arm. See, this is elbow. If you see my pointer, which is called as fulcrum, which is termed as fulcrum, which is a fixed point. This is load. Okay, this is load. Here is load, and here is force. Okay, so we need to lift this load. Okay, for that, this is your elbow acts as your fulcrum fixed point about which your this forearm is going to be turn. Okay, and this is force. So by this we are going to apply the force. Okay, to lift force or effort to lift this load. Just similarly, if you are doing a gym, so we are lifting a dumbbell, so same principle is written over here. This your forearm is going to turn about this fixed point called as fulcrum. Okay, so this is also this forearm also act as a what lever. Then this is now here you can easily understand that is this is a fixed point which is fulcrum, this is a force, and this is load which is to be lifted. Okay, now one again very common example of this lever is your hand pump. If you see, this is the fixed point. Okay, this is what fixed point called as fulcrum. This is effort, this is the end, that is we are going to apply effort over this, and this is a load which is we need to lift. Okay, so this is also an example of levers. So one again very common example is if you see auto rickshaws. Okay, auto, this is three-seater autos. If you have seen, So in that three-seater auto, that auto driver is used to lift one rod or bar to start that particular auto rickshaw. So what that is one simple metal rod which he just pulled to the upper side, okay, by impact, by just applying some impact over it, and your auto gets started. So that what it he pulls along upper side, that is also one type of lever. Okay, that is also one very common example of lever, which is turn along a fixed point called as fulcrum. So these are nothing but the levers. Okay, I hope that you are understood this. Now see what the lever is, what the straight lever is. Okay, what we seen in this diagram, please see, this is B, this is A, and this is F, this is W, and this is P. Now see, this is L2 and this is L1. Now what are the various meaning of this, all these notations placed over here? Please see, the points A and B through which the load and effort is applied are known as load and effort points respectively. So guys, I am repeating, the points A and B, this is point A and this is point B, through which the load and effort is applied are known as load and effort points respectively. So this is called as load and efforts point. This is load point and this is effort point. Why it is? Because load is denoted by letter W, so it will become load point, and effort is denoted by letter capital P, so that is why this point is become effort point. So this is load point A and this is effort point B. Now F, capital F is the fulcrum about which the lever is capable of turning. See guys, capital F is the fulcrum about which the lever is capable of turning. As we know, fulcrum is a fixed point about which your lever is going to turn. Okay, so where it is? Here is F, about which your lever is going to be turned. So this is what fulcrum. Okay, now the perpendicular distance between the load point to the and fulcrum. See guys, the perpendicular distance between the load point and fulcrum L1 is known as load arm. Please see, I am repeating, the perpendicular distance between the load point and fulcrum, that is L1, is known as load arm. See guys, between the perpendicular distance between the load point and fulcrum L1 is known as load arm. See guys, we know that what is the load point, that is A is your load point as we have seen in first point, and this is F for your fulcrum. So what is the perpendicular distance from this load point to F? That is, it is denoted by L1. See guys, it is denoted by L1. So this is the distance we have counted from this load point A to the fulcrum F, which is denoted by letter L1, is called load arm. Okay, is called load arm. And similarly, the perpendicular distance between the effort point and the fulcrum, that is L2, is called effort arm. See guys, similarly, the perpendicular distance between the effort point and fulcrum L2 is called effort arm. See guys, now we know that the B is your effort arm and this is fulcrum. So perpendicular distance from fulcrum to effort arm, or effort arm to your fulcrum, that is which is denoted by L2, is called as effort arm. Okay, so L2 is your effort arm and L1 is your load arm. Okay, this is the distances. Okay, so let us so we are, I think you clear about the idea, basic idea about the levers. Now see what next. Now according to the principle of moments, now see, if you use the principle of moments, as we know your levers are going to work on the principle of moments. So W into L1, so L1 is your, we know that load arm, is equals to P into L2. L2 is your effort arm, W is for load and P is for effort. Okay, W is stand for load, which is to be lifted. This L1 is the perpendicular distance from the load arm to the fulcrum. P is your effort, and this L2 is the perpendicular distance from the effort arm to the fulcrum. So we have equated this, what we left with, please see guys, W by P is equals to L2 by L1, which is equals to mechanical advantage. Okay, which is equals to mechanical advantage. Now mechanical advantage is equals to W by P is equals to L2 by L1. Now the ratio of the effort arm, see, I have mentioned this sentence in a different color. Why it is so? Please see, the ratio of the effort arm to the load arm, that is L2 by L1, is called leverage. See guys, is called leverage. The ratio of the effort arm, okay, the ratio of the effort arm to the load arm, that is L2 by L1, is called leverage. A little consideration will show that if a large load is to be lifted by small effort, see guys, A very vast meaning is hiding in this sentence. Please see, a little consideration will show that if a large load, okay, if a large load is to be lifted by small effort, if we want to lift a very large load by applying very small effort, then the effort arm should be much greater or longer than, see guys, then the effort arm should be much greater or longer than the load arm. Okay, if we want to lift a heavy load by applying a very small effort, then what is the condition for that? Then our condition is the effort arm should be much greater or longer than your load arm. Okay, then and then only it is possible to lift a very small very heavy load by applying just very small effort. Okay, then what next, please see. Now, application of levers in engineering practice. This is one of the very important type of what we say levers, important type of topic about the levers. Please see, guys, this is what application of levers in engineering practice. Application of levers in engineering practice. So see, the application of levers in engineering practice, which plays very important role in this topic. See guys, what you seen here, please see, A is denotes first type of lever, B denotes second type of lever, and C denotes third type of lever. So what do you mean by this first type, second type, and third type? This question has been asked so many times in MCQ type of examination also. If you prepare for any kind of examination, so you may found this question. Even I found this question so many times. So that is why I am telling you. So please see. First of all, we know that we should see that what it is. Please see, the load W and the effort P may be applied to the lever in three different ways as shown in figure. See guys, the load W and the effort P may be applied to the lever in three different ways. Please see how it is applied. You can see, let me first of all let me give you some basic idea about this. In this first type of lever, you can see your effort is here P, your W is here at point A, and F is in between your load and effort. In second type of lever, please see, your uh, effort is here, load is here, and fulcrum is at the right hand side of your load and effort. And in this third type of lever, you can see your fulcrum is at right side and your load is at leftmost side, and your effort is in between your fulcrum and what load. So why it is, and what are the various effect of these conditions for your design of lever? Let us see. So in these three ways, we can apply the load and effort on the lever. Okay, so the levers shown at A, B, and C figure are called as first type, second type, and third type of levers respectively. See guys, I have already told you that A denotes first type of lever, figure B denotes second type of lever, and figure C denotes third type of lever. Now what it is actually, please see. In the first type, let us see. Please pay your special attention over here. In the first type of levers, the fulcrum is in between the load and effort. See guys, I have told you. Please see, your fulcrum is between the load and effort. In this case, the effort arm is greater than load arm. See guys, in this case the effort arm is greater than load arm, therefore mechanical advantage obtained is more than one. Such type of levers are commonly found in bell crank levers used in railway signaling arrangement, rocker arm in internal combustion engines, handle of hand pump, hand wheel of a punching press, beam of balance, foot levers, okay, etc. If you seeing second type of lever, then in second type of lever the load is in between the fulcrum and effort. Please see, you are in this type of second type of lever, your load, this is W, your load is in between fulcrum and effort. Okay, so what effect of this? Please see, in this case the effort arm is more than load arm. See guys, the effort arm is more than load arm, therefore the mechanical advantage is more than one, similar to first type. The application of such type of levers is found in levers of loaded safety valves. Now what about third type? In the third type of levers, the effort is in between the fulcrum and load. Please see, your effort, this is effort is between fulcrum and load. So what happens? Please see, since the effort arm in this case is less than load arm, see guys, the effort arm is less than load arm, therefore the mechanical advantage is less than 1. The use of such type of levers is not recommended in engineering practice, because we have seen the length of your effort arm that should be longer than your load arm. Okay. However, a pair of tongs, uh, treadle of saving machine, etc., are the examples of this type of lever. So this is all about the basic of levers, that what are the various types of lever and how it is used and for what application it has been used. So I think this content is useful for you.